Hello, welcome to today's daily Leetcode challenge. Today we'll be solving question 300, longest increasing subsequence. I have a theory that in Leetcode, questions that come earlier in the sequence tend to be more generic because they were probably created earlier and they appear more in interviews. So this is a good question to follow along and really understand. Let's dive into the question. So 300, longest increasing subsequence, medium level question, and the description is pretty simple. Given an integer array nums, return the length of the longest strictly increasing subsequence. A subsequence is just a select few or many numbers from the input array that have the same property of being in order. So if we choose, for example, 9, 7, and 18, in the subsequence, 9, 7, and 18 have to preserve their order relative to each other. Not their index, but their order. So, I mean, very general and easy to understand. Strictly increasing means that they're increasing. Okay, example 1, we have a subsequence of 2, 3, 7, 101, and in the array 2, 7, 2, 3, 7, and 101 appear here. It's the longest one. There's also potential for an 18. I don't know why that wasn't picked, but maybe that gives us some insight into how the algorithm should work. Example 2 is 0, 1, 0, 3, 2, and let's see how fast I can do this. I would think that it's going to be 0, 1, 2, 3. The answer is 4. That seems to align. Example 3 is 1. All the numbers are identical, so if it's strictly increasing, that also means that you can't just have repeating numbers. All right. So how do I think about these sorts of problems? How to approach something like this? Let's start with naive solutions and see where some of the pitfalls are, if we can find out, or if we can come up with counter conditions or counter examples that would break those solutions. Let's have the first one be me iterating through the array and keeping track of the current longest increasing subsequence and its end. So for example, 9, or starting with 10, we would have the longest increasing subsequence length 1, and it ends with 10. Then 9 is less than 10, so we would replace the previous subsequence of length 1 with 9. Why? Because 9 now replaces what would ideally be the best starting point for our longest subsequence, because it's smaller than the 10. And what I'm describing right now is sort of this stack that I'm just, or this bucket that I'm carrying along with me. And in this bucket, I have the following. I have 10 initially, and I say that max len is equal to 1. Then I look at the next number here. I look at 9. I say that 9 is smaller than 10, so I would replace 9 with that. My goal is to have a ascending number of, or ascending number of, or ascending numbers in this bucket. So 9, and from there on we would only be increasing and increasing. We see that 9 is still of length 1, so this bucket still has the property of being of length 1. Let's look at now the next number. 2 is smaller than 9, so we would sort of like drop this 2 in there and see which numbers it would kick out. Well, it would actually kick out everything, so we have 2 here, max len of 2. Let's look at the next number. Let's look at 5. We're trying to drop in 5. Is 5 smaller than 2? No, it's not. So 5 would just sort of be dropped in there, and all of a sudden max length is increased by 1, right? So now our max length is 2. Seems like this approach is working so far. Let's look at the next. Let's look at 3. 3, can we drop in 3 there? Yes, but it would replace 5, and we're okay with that because it's not like, I mean, that's our algorithm. Max length doesn't change. We look at the next number, 7. Can we drop in 7 in there? Yes, we can. And wow, all of a sudden, not only do we, let me draw a bigger bucket now that we're in need. We now also increase the max length. Now it's 3 because 7 is being dropped in there. 2, 3, 7. And then, wow, 101. We drop it in there. It doesn't replace anything. It doesn't replace anything, so we get our answer actually. We get our answer, 101 goes in here. We're set. Max length is equal to 101, and it seems like everything is working. Now, would this work for everything? No, it wouldn't. Why not? Well, because there's a potential, and this is best explained visually, I think. If we were to think of these numbers as maybe a line graph, then there's an example here. Actually, example 2 is a good example, where we have a number like this. Let's say 1, then 2, then 1 again, and then what is it like? 4, 2, 4. I can see here this pattern that we have this line, then we have this line, this line, this line. And look, from here, and these are the same. I can see that the best way to do an increasing, or to choose the increasing ones, is these guys, right? But following our approach, where we replace the largest numbers in the stack with ones that appear later but are smaller, we would actually be, oops. Sorry, what happened? We would actually be replacing this value here with this value. So we would be popping this guy out and putting this guy in there again. And then that would lead us to only picking out these values, which is not ideal, which is not the correct solution. So this naive approach of keeping a stack and increasing that stack with or adding to that stack values that seem to be good at the moment but don't fit into the whole picture doesn't work. And I'm probably have already confused you enough. The approach here needs to look at the best possible solution over all of the previous numbers that we've gone over. And that kind of leads to the idea that this should be a dynamic programming solution. Let me now ask you, I guess, another question. And this is how you pretty much solve dynamic programming problems. If we have, let's say, a subarray some subarray here that's very secret, but I know two properties of it. I know its length, and I know its starting point, or what is the first value in that secret array. So I know its length is, let's say, 3, and I know that its start is equal to 2. Then, if I now try to pick out from if I now have this secret array here, and I want to use it as if it is an extension of, let's say, like the first 3 numbers that I have in my array. So let's say that this is the secret array, as if, and the first 3 numbers that appear in this array are here. They're different, but it's for the purpose of the example. So if I have these 2 knowns about my secret subarray, could I figure out what is the longest increasing subsequence of these 2 things combined? Well, let's see. If I was to choose 4, if I was to consider 4 to be in my longest subsequence, would this 4 eliminate, or would this 4 contribute to or play well with my secret array? Well, at first glance, why not, right? It's a number, well, actually no, at first glance, it's already obvious that it's not going to play well. Why? Because start is smaller than this value, and since our increasing subsequence has to be increasing and not have any minimums, then 4, 2, and then whatever follows doesn't work. Can we consider now 1? 1 is less than start, so we have 1, 2, and then our secret array has a length of 3, so could we now update this to be of length 1 and maybe of length 4 and remove these 2 guys entirely? Now only be considering 1? Why not, right? This seems like we have some prior knowledge about some secret array that has properties that help us decide whether to include or not include, or basically, if included, if this value is included, what is the best possible solution, given that we know everything about our arrays, everything that we need to know about our secret arrays. What I'm getting at is a dynamic programming solution that looks like this. We have an array that has these numbers, and then we have a DP array that tracks what the longest increasing subsequence is from each of the starting points. So something that is initialized with a 1, right? Because in here, if you were to choose 1 to be in the longest subsequence, it's a valid number that is increasing, so 1. And then from the 101, since we have this property, we know exactly what the number is here. We know what the starting position is with that, from that secret array, and we know what the length of that is. We can construct our next value that will go here. We know that 101 is greater than 18, so it can't contribute to the length of the longest subsequence array. But what that tells us is that that is the new starting point for our longest increasing subsequence. So we have a 1 here as well. If we were to look at the next number, as in like what is the next secret, or what is the next longest dynamic programming, what is the next value in the DP array from the back, we know that 7 is what? It is less than both 101 and 18, and it precedes both of them as well. So can we just say that 7 would contribute to the longest increasing subsequence, and therefore say that 2 plus whichever one of these we decide on? Well, actually it's going to be 101 because that's just the first one that appears, and since it fits the property of being further on in the sequence, being larger, and having a pretty and having a long increasing, or having a length that is greater than having a length that is 1. Well, actually, okay, hold on. So we would also need to consider 1 as well. We would also need to consider, we would need to consider all of them, actually. So maybe we can, for each one that we fill out, we just iterate over all of the values here. And since we keep track of all of the lengths and we know their subsequent starting points, it sort of gives us that ability to figure out what the longest subsequence is. I think that's enough talking for me. Let's try to get into the, let me get into the solution. Let's have, as promised, our DP array that starts with just the value 1. Let's also have the max length equaling 1 initially. And then let's have a for loop for I in reversed range from 0 to, let's say, len nums minus 1. That should give us the ability to do this. Now, what did I say here? That I'm going to be first looking at what am I going to be looking at? Well, now I've confused myself. I need to have a another for loop that figures out what the current max length is. What the current possible max length is. That is it different from this though? Let's have the current number first. The current number that I'm exploring is nums at I. The for j in, and now I have to pick out a range. It's going to be from I guess plus 1 to length of nums. Let's have an L here, length of nums. To L for j and I plus 1 to L. We're going to next num is going to be equal to nums at j. And if current num is less than next num, and okay, next num is probably a bad, let's say subsequence start. I like subsequence start because subsequence start gives us an idea as to what we're actually doing. If current subsequence is start, then let's see. I then want to say dp, I want this to be a dq. I want dp, let's have a cur length is equal to 1, because that's the length that we're currently exploring. Cur length is equal to max of cur len, and dp's okay, another change. I'm going to say 0 times L, and then dp at -1 is equal to 1. Then I'm going to say that from ji to L, that gives me immediate access to what my dp of j plus 1. What is this doing? This is telling me what is the possible current length of the number that I'm exploring, which is I, including the secret subsequence length, right? So the subsequence start and the subsequence length lives in dp, right? So the subsequence start nums j, and just like subsequence start, we have a subsequence length, the dp of I, y plus 1, because we're including I, or the current value, in there. And so once we've iterated through all of the values in the secret subsequence, or the secret array that precedes the current number that we're exploring, the current length should be the maximum. What is current length now going to be? Current length is going to be equal to dp at I. Dp at I is equal to current length. Is that correct? So we found the largest here. Oh, and yeah, obviously once we found the largest, we also should consider if the current length is actually the length that we want to return. Because what if, yeah, there we go. Let's return max length. See if this works. And it does not. We have an error somewhere. Let's print dp and see where we're going wrong. Presume that it might be somewhere with the So I'm definitely messing up somewhere here. 1 1 2. So at this point, at 3, we should be looking at a max. We should be looking at a 3 here as well, because 37101 is a valid subsequence. So what is going on here? I have the length of 0. I have my initial current length start on. Current num is going to be the sub num. I plus 1 to L. So let me do this. Print cur num, and let's also print secret array, which is just going to be nums with I plus 1 and L. Okay. Here, then we should see num. Oops. So I'm just trying to see here what is the potential current num 101, 18, 7, and 7 should be right. Then for 3, I'm getting, let's just do this. Secret, and then I also want to maybe print the what is in DP at the time, because DP DP I plus 1 and L. This should also work. This should also give us the understanding of what is, so 1, 1, 1, current number. Current number, DP of J, right? So the sub start, we're going from 7. Current length is current num, should be smaller than 7. Then the max, the current length is going to be 1 plus, what is the, why is current length not being updated to 3 here? Current length at this point should be 1, but dp of j plus 1 should be equal to 3, but it's not equal to 3. What am I doing wrong here? Okay, I want to then figure out what my current num is 3. I'm printing it. So I'm looking at this situation right here. I have the secret array that is numbers that appear there and the lengths that are associated with it. So in from my understanding, should I just bring this outside of the array, current num? I think so. Max length and current length. What in the world is going on? I think I got portion of this correct. So current length, I should be returning max length. There we go. I got it. What I was doing here that's wrong was I was reinitiating current length constantly to 1, whereas I should have only been doing that once, and when I am currently exploring a number, right? So current length gets updated to the best possible solutions, but not to the longest solution or the longest length, but not each time, just once. So this should work now. Awesome. And then returning max length instead of current length like I was doing before. Let's submit this, not available during execution, and this is a 30-minute video, but there was a lot of explanations and a lot of code. So beating 70%, not ideal, and it seems like I've actually solved this before. I'm not going to go into that. Let's cut it here. There probably is a better solution, because instead of iterating through all of the secret array, I could be optimizing it so that I don't have to go through all of it. But this was a lengthy video anyway, so I'll explore the other solution, I guess, later on when I catch this problem again. Alright, thanks for watching. Hope that was insightful and at least helped sort of see how someone thinks through this when they're solving it. Alright, thanks for watching. Please like and subscribe. See you later. Bye.